Chapter 8, Section 2. There's going to be two other triangles. Okay, I went through the Pythagorean triples with you. You've got the chart. There's two other triangles you need to remember, and these are specialty triangles. One's called a 45-45-90. Means 45 here, 45 here, and 90 here. Okay? And the other one is a 30-60-90. 30 here, 60 here, and your 90 there. These are also special triangles. Just like the Pythagorean triple showed you, these always hold true too. On the 45-45, the legs, let's say, are 1. 1 and 1. The hypotenuse will always be square root of 2, or some form of it. So if I was to say my leg is x and this leg is x, then this would be x square root of 2. So if you take a look, you might have 7. They might give you a 45-45 that looks like this. They say this is 7, this is 7. You can immediately tell what the hypotenuse is by 7 square root of 2. All right? It's whatever that leg is, square root of 2. Or they may do this. They may say this is x and this is x. And that's 7 square root of 2. What's my x? 7. See how quick we can do that? You're going to see these also on the ACT trip. All right? These kind of things are going to be up on the ACT. So you can quickly, again, find out what those legs are without having to go through the Pythagorean theorem. On a 30-60-90, let me draw this over a little bit. Now this is important to know. Opposite the 30 degree is always the smallest one, and that's a 1. All right? Opposite the 30 is a 1. Then we go to the hypotenuse. That's a 2. And then the third leg, or the second side of the leg is square root of 3. So we go the smallest side to the hypotenuse to the other leg. 1, 2, square root of 3. But just like the 45-45, this also can be written like this. 1x, 2x, x square root of 3. All right? We see a triangle out there, and I'm going to tell you, if you see it as a 30-60-90, you can immediately use this kind of stuff. So down here, maybe here I say, this is 14. This is x. This is x square root of 3. Can I figure out what x is? What's x? 7, right? Because my hypotenuse is 2x. Take half of 14 and we get 7. We know that this equals 7 and this here equals 7. 7 square root of 3 and 7 on the bottom. Real quick ways to figure it out. Now, you might see this. Does anybody have questions on how we did that? You see that? Here's what you might see. You may see something like this. Some number that has, let's say, 6 square root of 3 in it. Okay, or some square root of 3. And you're working with a triangle. What should come to mind first? 30-60-90 triangle because of this square root of 3. If you see something with a square root of 2 in it, then you know it's the 45-45. Okay? As you're doing the test trip, you start seeing something like this, you got to clue in on it. Because this might give you that tip to say, I know what kind of triangle I'm working with. All right? Especially if they're working with triangles. That's a clue. Square root of 2 is always or not always. Square root of 2, you got to clue in on the 45-45. Square root of 3, you got to clue in on the 30-60-90. because those are in there. Okay? Questions on it? All right. What does this want to do? Draw a horizontal line segment on the center grid paper so that the endpoints are the intersection of the grid lines. Use a protractor. Nah. Nah. All right. That's good. 5, 6, 7. These are working with 45, 45s. And 14 through 17 are working with 30, 60, 90s. All right? Do the 8 problems. The 4 on the first side, 4 on the second.